a Serbian-American inventor who would never truly see financial gains from his genius. Working at the twilight of the 19th century, he would contribute to an invention that has become a cornerstone of modern civilization. Nikola Tesla's alternating current, or AC, power technology remains one of the most influential inventions in over 100 years, forming the basis of electrical transmission through power grids around the world.
I think the easiest way to think about how important it would be is to imagine what would happen if the electricity went off tomorrow and never came back on. Every single one of us in a modern industrialized country relies on a power grid that uses long-distance transmission using AC current, generally speaking.
But the path from Tesla's ideas to reality was a dramatic one. When Tesla arrived in New York in 1884, he began working for Thomas Edison. Edison had already invented direct current, or DC electricity, but it only worked at a single voltage and couldn't be transmitted over long distances. He hired Tesla to fix this problem. Tesla already had ideas about how to transmit electricity using an alternating current and viewed DC electricity as inefficient. It wasn't long before the two inventors went their separate ways. An already acrimonious relationship was strained even further when Tesla sold his patents for his alternating currents technology to businessman George Westinghouse in 1888. Edison, desperate not to lose his DC electricity monopoly, began a protracted smear campaign against Tesla and AC. This period would later be known as the War of the Currents. Ultimately, the capacity of Tesla's AC electricity to transmit a powerful current over long distances with little loss would see him and Westinghouse emerge victorious.
Tesla's greatest invention would be the AC current power generation, and in particular, the working hydroelectric power generation station that he and George Westinghouse set up at Niagara. It's really the world's first large-scale, commercially successful electrical power generation system that could transmit the electricity at a distance. Essentially the same model that we use anywhere in the world today.
Nikola Tesla was a prolific inventor and engineer who earned more than 700 patents from his work. Not only responsible for AC electricity, he also made advances across countless fields, including wireless communication, lasers, X-rays, radar, and robotics. Above all, he was a genius beyond his time. His ideas and his work were so profound that they were little understood and often mocked by his contemporaries. Inventions that are the building blocks of technology we rely on every day. A scientist who stepped beyond the boundaries of known science to completely redefine the universe. He was a celebrity and icon of the 20th century, an unparalleled intellect whose work continues to form the building blocks of modern physics. Albert Einstein was working in a patent office in 1905 when he embarked on a prolific period of scientific inquiry that would later be referred to as his miracle year. Publishing 5 papers exploring his theories of how the universe worked at both the largest and smallest scales.
The two big inventions in physics of the 20th century are quantum physics, which is the physics of the very small, of atoms and particles, and the physics of the very large, which is general relativity. Now, general relativity, no-brainer, Einstein did it, but he was also one of the key figures in quantum physics. He's the person who essentially figured out that the photon, which is the fundamental particle that carries the electromagnetic force, had to exist.
In his papers, Einstein described methods for measuring the size and movement of molecules, and proposed that, at an atomic level, matter and energy are interchangeable. The idea behind the most famous mathematical equation in history, E equals mc squared. An equation that made atomic energy possible. Einstein's most widely circulated paper outlined his special theory of relativity, proposing an intrinsic link between space and time in which observations differ depending on where objects are moving in relation to each other. By 1915, Einstein had expanded this into an absolute unified theory on the way objects in space and time interact that would redefine our view of our place in the universe. This was Einstein's general theory of relativity.
The general theory of relativity basically says that gravity isn't a force. Gravity is simply if you put stuff in space-time deforms. And then if something passes through space-time, it feels the deformities of space-time. And so imagine putting the sun in space-time. It'll deform space-time, and then sending the Earth through space-time, and it'll coast around the warps of space, and it'll go around in a circle. What you see is a big object pulling a small object, but what actually is happening is they're interacting through space and time. Now, those are words, and it's easy to use these words, and a lot of people can understand these words, but whether they actually understood general relativity is a different matter.
What do you think of the Einstein theory?
I don't think anything of Einstein's theory because I can't understand it.
Excitement about Einstein's general theory of relativity didn't truly take hold until English astronomer Arthur Eddington observed it in action during a solar eclipse in May 1919.
He showed that it was exactly as Einstein had predicted in his papers. This news took the world by storm. Einstein became a superstar overnight.
Einstein had already achieved the most significant work of his career, but the extent of his importance to physics was only beginning to be uncovered. As they were, Einstein, the cultural icon, emerged.
People outside academia cottoned on that there was something important, and I think Einstein very rapidly became this pop hero, this folk hero. Everyone knew who Einstein was.
Einstein was a pacifist, but in 1939 he signed his name to a letter to President Franklin Roosevelt warning that Germany may be developing an atomic bomb.
It is impossible to achieve peace as long as every single action is taken with a possible future conflict in view.
His warning led to the Manhattan Project and the creation of the atomic bombs dropped on Hiroshima and Nagasaki in 1945. Einstein's theories outlined the most fundamental aspects of the universe, but in some ways are so large and complex that we have yet to fully realize their applications. His general theory of relativity is the framework by which we can understand, measure, study, and even predict the forces at work in the behavior of the universe. An understanding that may someday enable us to interact with those forces and travel out beyond the reaches of our own galaxy. A scientist whose career began with one of the most important discoveries in astrophysics and ended with one of the most destructive scientific advances in history. In the 1930s, J. Robert Oppenheimer was a quantum physicist studying neutron stars at the University of California in Berkeley.
It had been claimed that these objects could emit a lot of light. So Oppenheimer set to work trying to figure out how he could figure out what these objects actually did. And what he realized was two things. One is that if they got too big, they were unstable. And then he said, well, if they're unstable, what happens? And he realized that these objects, if they get too big, they collapse and form black holes. And for the first time, someone had worked out where black holes could come from.
A theory that wasn't fully appreciated until astrophysicists started looking at the possibility in the 1960s. The name black hole was given to what Oppenheimer proposed would happen when a neutron star collapsed.
Interestingly enough, some people think that his papers on gravitational collapse and ultimately the formation of black holes are more important than all his work on quantum physics.
This may have been Oppenheimer's most notable contribution to science if it weren't for the Manhattan Project. In 1942, the US Army drew together a team of physicists in a race against Nazi Germany to harness nuclear energy for military use. Oppenheimer was made responsible for running the lab and scientists involved in the project. The combined efforts of Oppenheimer and his scientists saw the first nuclear explosion successfully carried out in New Mexico on the 16th of July, 1945. By then, Germany had surrendered, but Japan had not. On the 6th and 9th of August, less than 2 weeks after their first successful test, the US dropped 2 atomic bombs on Hiroshima and Nagasaki.
Their leader could think only of a line from a Hindu poem. I am become death, the shatterer of worlds.
Japan surrendered, and Oppenheimer became a national hero. He resigned from his position in October that same year. After the war, Oppenheimer advised that atomic energy be controlled by an international agency, was vocally against the development of an even more destructive hydrogen bomb, and opposed nuclear aircraft and submarines. A stance that saw him become a pariah of the scientific community. His government security clearance permanently revoked.
I think the only hope for our future safety must lie in a collaboration based on confidence and good faith with the other peoples of the world.
J. Robert Oppenheimer was a talented physicist who made a fundamental contribution to his field long before his involvement in the Manhattan Project. His name now forever linked with one of the most notorious scientific projects in the world. An invention that would see him celebrated, but which he would come to regret, and would ultimately ruin his reputation and end his career.
Know that as long as men are free to ask what they will, free to say what they think, free to think what they must, science will never regress, and freedom itself will never be wholly lost.
As the 19th century turned to the 20th, she was a woman in a man's world, facing opposition, doubt, and incredible personal risk to become one of the most important scientists. Marie Curie and her husband Pierre were working at the School of Chemistry and Physics in Paris when Marie began studying the mineral pitchblende. It contained uranium ore, but Marie was convinced that its high level of radioactivity meant that another substance was present. The pair set out to prove her right, and in doing so, added 2 undiscovered elements to the periodic table: polonium and radium. In 1903, they were awarded the Nobel Prize in Physics for their work. After her husband's death in 1906, Marie continued their research and was appointed to his professorship, becoming the first woman to teach at the Sorbonne. In 1911, she was awarded the Nobel Prize for Chemistry for creating a means of measuring radioactivity, making her the first woman to win a Nobel Prize as an individual, and the only woman to win in 2 categories. At the onset of the First World War, Marie turned her attention to helping develop mobile X-ray, traveling to the front lines herself to set up the units. After the war, Marie continued to win awards for her research and teaching work. But she also faced opposition from the male scientific community in France and never saw much financial benefit from her efforts. Marie worked with some of the most dangerous substances in the world, often handling them with little or no protection. It would ultimately be the cause of her death in 1934. She strove to realize her gift for science, no matter the personal cost, or the social forces that opposed her. Her legacy endures today as a role model for women aspiring to work in male-dominated fields.
I think she did a great deal for women by her example, by excellence, showing that you could become what she became, which was pretty extraordinary.
Here today, the famed scientist Dr. George Washington Carver carries on his research. Born a slave, Dr. Carver has made important discoveries which are being used to the benefit not only of his own race, but the industry and agriculture of all the South.
George Washington Carver arrived at the Tuskegee Institute as a teacher and researcher in 1896. He remained there until his death in 1943. When Carver began teaching at the end of the 19th century, the South was still heavily reliant on its cotton-growing industry. But repeatedly planting a single crop had taken its toll. Soils were depleted and erosion was increasing, destroying farmers' livelihoods. Carver solved this problem by encouraging growers to plant different crops, among them peanuts and sweet potatoes. To create a market for the new produce, Carver set about discovering as many uses for them as possible.
The work of Dr. Carver is well known. While at Tuskegee, he has contributed much to the science of nutrition. Using an improved process, these scientists get more alcohol from the plentiful sweet potato than ever before.
Developing 300 products derived from peanuts and 118 products derived from sweet potato. His work on crop diversification and soil preservation is widely considered to have saved agriculture in the South. Carver was also an early innovator in the field of genetic engineering, cross-pollinating different species of plants by hand in his laboratory. Carver's work earned him a reputation, and he was regularly sought out for his knowledge and advice. By the late 1930s, Henry Ford had started corresponding with Carver, interested in the industrial uses for plants like soybeans. The pair worked on developing biofuels derived from plants. While it didn't take hold at the time, it was another example of Carver's vision. Ford was not the only person to value Carver's important work. He advised Mahatma Gandhi's supporters on nutrition between hunger strikes, and American President Theodore Roosevelt on the nation's agricultural matters. He was even invited by Joseph Stalin to oversee cotton plantations in Russia in 1931, an invitation he turned down. Carver was one of the most prominent and prolific agricultural scientists in the world. Carver's support for sustainable agriculture and renewable resources put him years ahead of his contemporaries. His work and his vision more relevant today than ever before. A mathematician who strived to understand the capacity of the human mind. He created a device capable of taking us far beyond our limitations. Alan Turing began studying mathematics at Cambridge University in 1931, quickly turning to the possibility of digital computation.
Turing was part of a group of people in the 30s and 40s that were exploring what thinking is, what calculation is. So they were generally looking at nervous systems, they were looking at feedback in machines, calculating machines in this very kind of open-ended way because it was all new.
In the mid-1930s, Turing was attempting to understand the limitations of a human's ability to compute mathematical problems. He created what he called the Turing machine and proved that it could compute everything the human brain could, marking out the limits of human computation. In 1938, Turing joined the government code and cipher school. With the outbreak of World War II, he moved to their wartime headquarters at Bletchley Park.
During the Second World War, he was involved with the sophisticated calculators for cracking the German code on the Enigma machines. He helped develop a very, very sophisticated calculating machine, not a true computer, for cracking that code.
By 1942, Turing's machine was decoding 84,000 messages a month, or 2 messages every minute.
His work cracking the German code shortened the Second World War considerably.
After the war, Turing turned to work as a computer designer. In 1946, he finished designs for a digital computer that could store programs in its memory. This was modern computing. Turing was also an early pioneer of artificial intelligence, or AI.
He came up with a model for AI, which we now know as the Turing test, which is sort of sidestepping the issue of whether a computer would really think like a person, and just saying if it could fool people into thinking that it was a person, then it must be doing a pretty good job of emulating it, and that it's almost irrelevant whether it really is thinking the same way.
Turing's work is now considered to be the basis for modern computer science.
I think a lot of people don't realize how mixed together, cognitive science, neuroscience, mathematics, what we now know as computing, were at the time. And there was a lot of bouncing ideas off each other. And Turing was part of that, and I think that's one of the big kind of intellectual movements, certainly of the 20th century.
The fact that Alan Turing changed the course of the Second World War is enough to make him a significant figure of the century. But he was also an incredible thinker who laid the groundwork for one of the most important technological advancements in human history. He dedicated his life to the study of diseases, seeking preventions, not cures, leading to one of the country's most celebrated developments in immunology. Polio. Highly contagious and equally devastating, it would strike in the summer months, sweeping through the population and then disappearing again. Some recovered, but thousands who caught the disease would be permanently paralyzed or killed.
Polio was the panic virus of the first half of the 20th century. It was considered a plague. It kept children out of schools because parents were so worried about their children catching it.
In 1947, Jonas Salk began studying the disease. Within 4 years, he had managed to develop a vaccine using polio virus grown in a lab and then killed. A year later, he was testing the effectiveness of the vaccine. In those days, tests were immediately performed on human subjects.
Well, Salk developed the vaccine by first testing it in people who'd had polio before, so it was safe. Testing it then in people who hadn't had polio, including himself, his wife and his children. And then the large field trial that he oversaw involved 1.8 million children.
Volunteer nurses and doctors donated their services for the largest field test in medical history.
The vaccine was finally approved for general use in 1955.
Will this new procedure bring the vaccine closer to full effectiveness?
Yes, it will. That's fully the expectation, and more than that, it will bring it closer to the point of producing long-term immunity, which is really the objective that we hope ultimately to achieve.
Before the vaccine was made available, there were around 50 to 60,000 cases of polio each year in the United States alone, leading to over 15,000 cases of paralysis and nearly 2,000 deaths. After a decade of vaccine use, the number of polio cases per year was under 1,000.
Salk was such an advocate for vaccination that he believed it should be mandatory for children to be vaccinated. He considered that you shouldn't patent a vaccine. He said it was like trying to patent the sun. He thought that we should give this benefit to the world as quickly as possible.
Salk was crucial to the development of a successful vaccine against one of the most destructive diseases in modern history, work that would be continued and perfected by others after him, aided by his incredible generosity with his discovery.
Salk was certainly a hero of the mid-20th century. He was lauded far and wide by politicians, by the general public, by the media. In fact, he found it quite uncomfortable he received so much adulation. But he worked on, and he devoted his energy to new diseases, and his own lab, his own research institute, subsequently produced another 5 Nobel Prize winners. It's one of the tragedies of the 20th century that Salk himself didn't get a Nobel Prize.
A scientist underappreciated in her time, her meticulous precision and patience would see her make one of the most important discoveries in the history of medical science. By the time Rosalind Franklin was 25 years old, she'd been awarded her PhD and was working in a lab in Paris. Here she learned to use X-ray crystallography and diffraction, a process that involved crystallizing a substance and then shooting X-rays through it onto photographic paper, creating an image that could be used to interpret the molecule's three-dimensional structure. In 1951, Franklin moved to a lab at King's College in London.
Well, Rosalind Franklin arrived at King's College really with very impressive technical capability in terms of X-ray crystallography. And she was somebody throughout her career who demonstrated that, not only was she was a gifted mathematician and very intelligent, but she had what's termed golden hands. I think she could actually get experiments to work. She could do things that other people couldn't do.
At King's College, Franklin and her lab assistant set about studying DNA using X-ray crystallography. They took hundreds of photographs, each requiring up to 100 hours of X-ray exposure to create. One stood out among the rest, known as photograph 51. To some, the photograph looked like a spotted X pattern. To anyone who knew how light diffracts through a coil shape, it was a clear indication of a helix structure. One such person was scientist James Watson. When Franklin's colleague Maurice Wilkins showed him the image, Watson knew exactly what it meant. Watson created the first model for DNA structure with lab partner Francis Crick in 1953. In 1962, Watson, Crick, and Maurice Wilkins were awarded the Nobel Prize for Medicine, 4 years after Rosalind Franklin's death at 37 years old. Photograph 51 has been referred to as the most important photo ever taken. A piece of work that was like a Rosetta Stone for DNA modeling, a key to interpreting the research that others had conducted to that point. For many years, Rosalind Franklin's name and her critical role in discovering the structure of DNA were lost to history. But the importance of the field she helped to unlock is well known.
I can't think of really anything that's had a similar impact in the 20th century. The discovery of DNA then allowed us to understand how DNA is replicated and transmitted from generation to generation. Discoveries made through an understanding of DNA are now pivotal in terms of medicine, predicting genetic disease, and in terms of therapy such as gene therapy. So it's just had a truly massive contribution.
For most of human history, bacteria was our most dangerous enemy, a killer that could turn a paper cut into a death sentence. That we have prevailed over this scourge is owed to a scientist who turned a fateful discovery into one of the most significant leaps in medical science. Howard Florey, with lab partner Ernst Chain and a team of scientists, began investigating natural antibiotics in 1938, work that had started a decade earlier with another scientist, Alexander Fleming. He had discovered that mold growing on a sample of bacteria, Staphylococcus, in his lab, had destroyed the surrounding bacteria. The active substance in the mold would be known as penicillin.
He tried to develop it as a topical antibiotic for people who had wounds, especially war wounds. However, after a few short years of trying to purify it, he gave up, and it became forgotten for most of the 1930s.
Where Fleming had failed, Florey and his team were determined to succeed. They set out in 1939 to isolate and extract penicillin in quantities high enough to be used as treatment for bacterial infections.
Florey and his team, working first in the laboratory with mice and other animals, worked on refining the growth of the penicillin mold and then extracting the chemical. In 4 short years, they reached a point where they could do some trials in humans. Very, very impressive work.
In Britain during the Second World War, there were inadequate resources to produce Florey's new antibiotic in large quantities. So Florey and one of his scientists took the risk to fly across the Atlantic in a blacked-out plane, seeking backers for the drug amongst US drug companies.
It became very clear early on that this drug was effective and it was safe. It could be used to treat very serious infections of the skin, of the blood, of the brain. And these infections responded quickly to the antibacterial activity of penicillin.
By late 1943, Penicillin was being mass-produced and put to use to treat soldiers wounded in the war. Australia, Florey's country of birth, was the first to make the antibiotic available for civilian use. Other countries soon followed. Penicillin was the first in a new era of medical science: antibiotics. They are now an accepted part of our everyday lives, treating everything from a child's ear infection to a serious infection of the blood. Made possible by Howard Florey.
Co-discoverers of the miracle drug penicillin share their $30,000 prize. Dr. Alexander Fleming of Britain, Dr. Ernst Chain of Germany, and Dr. Howard Florey of Australia.
His passion for astronomy would lead him to make some of the most important discoveries in history, forever altering our understanding of the universe. Edwin Hubble returned from World War I in 1919 to work at the Mount Wilson Observatory in California. They had just installed a telescope that would make Hubble's work possible.
Within this 750-ton dome is the 100-inch Hooker reflector. This is the world's largest telescope.
Hubble would use this new technology to seek beyond the edges of our galaxy.
Some people thought that our galaxy was all there was, that we lived in this island galaxy in the middle of nothingness. Hubble, in his first set of measurements, figured out that our galaxy is one of many.
It began with a single star, spotted in a nebula beyond the Milky Way. Hubble measured the distance to the star, establishing that it was 1 million light-years away, far beyond the edges of our galaxy, revealing that what were previously thought to be nebula were in fact other galaxies. He began to measure these newly discovered galaxies in relation to each other and to our galaxy, the Milky Way.
And what he found is that these galaxies were all moving away from us, and the further away they were, the faster they were moving away. And it turns out that if you have this relationship, which is the further away an object is, the faster it's moving away from us, that's the hallmark of an expanding universe.
With this discovery in 1929, Hubble completely blew away conventional opinion about the static nature of the universe, proving a prediction of Einstein's general theory of relativity that Einstein himself had doubted was possible. The relationship of receding galaxies is now known as Hubble's law.
Hubble's discovery of the recession of galaxies is hugely important. It is one of the great scientific discoveries of the 20th century. A lot of what we do in cosmology is trying to repeat that level of discovery and that level of excitement.
Through his work, Hubble significantly reframed our understanding of the universe and our place in it. Hubble's legacy lives on, not only in the fundamental importance of his discoveries, but in his namesake, the Hubble telescope, the first major optical telescope to be launched into space.
Were he still alive, Hubble would be excited at the endless discoveries likely to be made as modern astronomers prepare to take a step across a new celestial threshold.
Discovery, go for Hubble release.
It sits high above the Earth, seeking the far reaches of the universe, recording the wonders and details of other galaxies. Galaxies we know to seek out thanks to Edwin Hubble. One of humanity's finest moments would emerge from the most dangerous period of the 20th century. The attention of the world fixed on a single man as he took a leap into the unknown. 1960. For years, the Soviets and the Americans had been jostling to be the first to send a human into space.
Russian scientists claim that these dogs have blazed the trail for cosmic flight by man. Having whizzed around the Earth 17 times, we're told, at a height of 200 miles, they were safely back with quite a story to tell, if only they could tell it.
The Soviets had a group of 20 potential candidates for the task. One of those men was Yuri Gagarin. He was preparing for an unprecedented and incredibly dangerous challenge.
The earliest astronauts
were well aware that they were sitting in a little tiny capsule on top of fundamentally a converted intercontinental ballistic missile. I mean, these are the same rockets that were poised to set off a nuclear war.
Then, on the 12th of April 1961, Gagarin was strapped into the cramped space capsule on the top of a ballistic missile, ready for launch.
Was it hazardous? Yes, it was. But he was prepared for the task.
There was no countdown, just a series of commands from the control room, and Gagarin's rocket was propelled up into the sky. He would ultimately orbit the Earth for a total of 108 minutes. In that time, Gagarin became the first human to see the sun rise over the Earth.
The space programs of the United States and the Soviet Union was one of intense competition for the hearts and minds of the rest of the world. When the Soviet Union was the first to launch any space vehicle with Sputnik in 1957, and then followed that just a few years later with Yuri Gagarin as the very first human being in space, it was a staggering blow to the pride of the United States.
When Gagarin returned to Earth, he became an instant celebrity. Sent on a global victory tour where he was celebrated in the press and on the streets.
The man drawing the crowds in Cyprus is Yuri Gagarin, spaceman #1, no less. Having had a good look at the Earth from space, he's now having a good time orbiting all over its surface.
Yuri Gagarin was 27 years old when he took that fateful mission into space. It has been speculated that he was chosen not only for his skill and talent in training, but also his working-class background. Origins that suited the idea that under communism, people from humble beginnings could succeed. But in the intervening years, the politics fall further to the background, leaving only Gagarin's remarkable act.
And I think what's happened is that with the perspective now of many, many years past the Cold War, individuals have said, well, what Yuri Gagarin did was something that humanity accomplished. So I think the image that we in the West have of him has changed from being the representative or tool of the Soviet Empire or the communist state to a human being that accomplished something extraordinary, being the first ever human in space.
Port 13 is in. Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. That's one small step for man, one giant leap for mankind.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
July 20th, 1969. The world watched as astronaut Neil Armstrong stepped out of the Apollo 11 lunar module and onto the surface of the moon. It was a turning point in history. The final step in the space race between the US and the Soviet Union that had pervaded the 1960s.
Reaching the moon with the first human being was a demonstration that it was the United States, not the Soviet Union, who was best poised to lead the world.
Neil Armstrong was a US Navy pilot in the Korean War, turned NASA engineer, test pilot, and astronaut, with a bachelor's degree in aeronautical engineering and a master's degree in aerospace engineering. He'd been a pilot on the Gemini 8 mission into space in 1966, before transferring to the Apollo program.
The selection of the Mercury and Gemini and Apollo astronauts was a very, very rigorous process. You were dealing with military pilots who are extremely competitive in their nature, and a series of tests to push them to their limits and to see if they could remain cool and calm under some of the most dramatic and otherworldly experiences you can imagine.
Do you harbor any fear?
I think our training and all the
all the work that goes into the preparation for flight does everything it can toward erasing those kinds of possibilities.
That Neil Armstrong was the man chosen to walk on the moon for the first time was a reflection of his experience as a pilot, his temperament, and his ability to withstand extreme physical testing. But his presence in that moment and in that place was also owed to the many scientists, thinkers, and dreamers who put him there.
I mean, this is actually the ultimate team sport. Astronauts tend to be focused on as individuals, but if you look at the group they work with, including thousands of engineers, there is quite a group effort to make space exploration happen.
For as long as we have told stories, written poems, and performed sonatas, the moon has been the object of our fascination. Visible from Earth, an otherworldly feature in the night sky that we pondered long before we understood the universe. With the weight of that history behind him, Neil Armstrong took his first steps onto its lustrous surface.
When Neil Armstrong first stepped on the moon, became the first human being ever to set foot on another world. I cannot think of many other accomplishments that are that dramatic and that have had such an impact, both in the near term when it happened in 1969 and then throughout the 20th century.
It may have been a moment fueled by the rivalry between two great superpowers, a political moment for America to plant their flag on the surface of the moon. Yet it was also a moment not only in the history of the 20th century, but of all human history, a pinnacle of human achievement, symbolized by the man who took those steps, creating that rarest sliver of history that can be owned by all of humanity.